Good morning, everyone. Happy Friday Astronomy Day. I'm sorry, Saturday Astronomy Days. I'm still stuck on yesterday. It's a penultimate day of the event. We are so excited you're joining us here this morning. So I'm Carrie. I'm an educator at the museum, and we have an icebreaker question for you. What excites you the most about space? So put your answers in the chat. And I will, this is the second time I've done this. I'll go to the beginning of my little tutorial here. And while you are answering that question, I'm going to go through very quickly and do a Zoom tutorial. So this program is live caption. So if you'd like to use the captions down here at the bottom, click closed captions and click show subtitle. The subtitles will look like this. In the upper right, there is a, if the videos are on top of the presentation, you can go up to view options and click side by side mode. That moves us over, and so the presentation isn't obscured. You can also change the size of the presentation versus the videos. Lastly, we want to hear from you. Please talk to us in the chat. We want your questions, especially in this program because it's a panel. And so our speakers will be answering your questions today about astronomy. So put those in the chat, put your comments in there. Just please keep it on topic and please be kind and respectful to everyone in the program. With that, I'm going to, first of all, let's check the chat and see what excites folks about space. Let's see, black holes, planets, galaxies, and stars. Oh, such wonderful answers. I have to say that, we have the sun is burning hot. So I want to answer too. What excites me the most is just the possibilities of discovering new things that we don't know. And there's so much out there, and it's just so exciting to learn about all the new things that we didn't even know was possible. So with that, I'm going to introduce our panelists. So we have a panel of students from UNC who are in astronomy and physics, and they are here to answer your questions. This is a really fun and exciting program, so bring your questions. So why don't you take it over?
Hi, everyone. I'm going to share my screen really quick and we can get into introductions. I've ordered this from most senior level student to, I guess, newest. So I think McKenna is going to start first.
Hi everyone, my name is McKenna. I am a fourth year graduate student. I work in the Young Worlds lab at UNC Chapel Hill. We study young planets. Specifically, I study young star clusters, clusters like the Pleiades that you can see in the sky. And the planets within those clusters to sort of learn about how the clusters, how old they are and how the planets sort of change over time, which is really important open question in astronomy right now. In order to do that, I spend a lot of time using the telescope, specifically the SOAR telescope that UNC has access to in Chile. And so I've sort of got a picture here of one of those observing nights. Spend a lot of long nights, the telescope getting data on all the different members of these star clusters. And the data that I use looks something like this image here on the bottom left. I take spectra, which is sort of a picture of how the light, the brightness of the star as a function of wavelength. So sort of more red light is on the left side of that and more blue light on the right side of that image there. And so that tells me information about the star. Specifically here, this particular line that I have marked out, that's tells me about the age of the star. And then when I am not doing astronomy, I like to do some baking.
Hi, everyone. My name is Riley Milburn, and I'm a third-year graduate student, also in the same lab as McKenna. but I like to, I study young exoplanets. I like to study young exoplanets because they allow us to basically piece together planet evolution and formation at its earliest stages. And one mechanism that I'm particularly interested in studying is this idea of photoevaporative mass loss. Basically, there's a theory that young exoplanets that orbit really close to their host star might be losing a lot of mass very early on. And so I'm basically looking for signatures of this observationally. Like McKenna said, I use the SOAR telescope sometimes for my work. McKenna had a picture of us in the remote observing situation, but this is actually a picture of the telescope in Chile. Previously, I've done a little bit of work with pulsars and gravitational waves using the NICER telescope, which is a really cool X-ray telescope in space. And when I am not studying astronomy, I love to create and perform music.
Hi, I'm Sterling Adams. I am an undergraduate sophomore at UNC. Right now, I am studying astrophysics and aerospace engineering. Back to the SOAR telescopes in Chile that Riley was just talking about, I have used some of those as well as the Skynet telescopes to take some photos. These are two of them that I've taken. And also, outside of school, I'm currently working with NASA's L-Space program, which has been a lot of fun.
Hey y'all, my name is Salem. I go by he, they pronouns. I'm a sophomore astrophysics undergrad at UNC. I really like, I'm also joining the Young Worlds Lab alongside Riley and McKenna. I start research this summer, and I'm specifically going to be looking for young stars and indicators for them. I work at Moorhead Planetarium. You can see that a picture of the planetarium on the bottom right. I really like Star Wars and I really like to make music. And my dog is next to the picture of me. So that's me. Thank you guys.
Hi, everyone. My name is Callan Baruch. I'm an undergraduate freshman at UNC studying astrophysics. I've done a little bit of research before on looking at the rotation of our Milky Way galaxy to try to corroborate that with something called dark matter that we think might exist out there in the universe. If you actually look at the top right, those are two telescopes that I've used to do that in the past, located at the Pisgah Astronomical Research Institute. I really like math, which is why I got into astrophysics. And outside of that, I like to play tennis, read, and eat food.
I think that's all our introductions.
Awesome. So everybody just put your questions for the students in the chat. I have a question. I want to know what excites all of you the most about space, because that was the question you asked us, right?
Yeah, so I think what I really like about space, aside from just being hands-on, well, I really like being hands-on with all the equipment and taking my own observations to learn more about, I guess, just how things work and how things came to be, getting that better understanding of just how the universe is. And I think it's really cool that we have physical like telescopes and instruments that allow us to do that.
I'm really interested in exoplanets specifically. I think it's really cool, like all the different kinds of exoplanets that we might have that might exist outside of our own solar system. Like there's a whole list. And so I'm really interested in starting to look for those. So.
Yeah, I mean, space is really cool, planets and all that stuff. Although I will say that I think one of the coolest things for me about studying astronomy is that we have to look out at the universe and we only get this very limited information from the universe. We only get light. And from that little bit of light, we have to try and figure out, what's going on out there? What is this star doing? How do stars work? How do they form? How do planets work? And we can learn all that just from getting, very limited light information. So it's sort of a puzzle, how can I take this light and turn it into useful information?
I think I'm most interested in the exploration of space, just the idea of space travel. There's so many components that go into it, and I just think all of them coming together to create different missions is very interesting.
Yeah, not to sound cliche, but I just really kind of like how much we don't know about space. And the same kind of remains true for all the sciences we do. We don't know everything about anything, but space is so different from everything down here. It's really fascinating to be able to look up there and, like McKenna said, use light of all things to try to figure out how we're here and why everything happens the way it does.
So such cool answers. Okay, so we have a friend from the YouTube chat that wants to know, how much does the moon weigh? Oh, Riley, I think you.
I can go for that one if we want to. So the moon in space actually doesn't technically weigh anything. It's in orbit, which means it's kind of always falling towards our planet, but going around it at the same time. If you put it on the planet and wanted to see how much it would weigh on there, it would be a lot. It would be about 7 with 22 kilograms after it. I'm going to be honest, I did Google that number. I don't have that memorized, but a lot. It is very big.
Very cool. What is a fun answer. So Frank is wondering, how did you get interested in studying space? Of all the things you could choose to study, why is it space that you chose?
So I think that I first got interested in space generally just from science fiction and science fiction movies. I think they're a lot of fun. And that definitely piqued my interest. It is stuff like the science fiction movies, etc. But I really didn't take my first astronomy class and really get into it until college. My sophomore year of college is actually when I took my first astronomy class. And I think what excited me the most about learning more about astronomy is just, actually looking through a telescope for the first time and seeing the planets and Saturn's rings and stuff. I had never done that until college. So I thought that was super eye-opening and really cool.
Yeah, I have to agree with Riley. Watching different movies growing up really piqued my interest initially. I remember getting a telescope for Christmas when I was younger, and I always liked going outside with my dad and looking up and seeing all of the different things in the sky. More recently, as I've gotten further along in my major, I've been able to utilize different telescopes, and I guess just learning new things about what is out there has been just really interesting to me.
For me, when I was younger, I always liked looking up. I used to want to be a meteorologist actually, so just weather and stuff. And then I was at some point, I guess I was what else is out, what is beyond the clouds and stuff. And so that kind of started me looking into constellations and such like that. And that kind of just eventually led into physics and astrophysics.
Yeah, I think sort of similar to everyone who has talked so far, and to a lot of people who are not astronomers but who are interested in space. I'm interested in space because I grew up in a very dark sky area, so I could see the night sky very well. You could see the Milky Way from out back where I grew up, and so that sort of started my interest in space. I think that's
you have to tell us where you grew up with the dark skies.
I grew up in the Adirondack Mountains in New York. So one of the darkest sky places east of the Mississippi in the United States. Very lucky that way.
So like everybody said, I watched movies when I was a kid, and space always seemed really cool, but I actually never really thought I would do anything with space. And then my sophomore year of high school, I got really lucky. I got to do a research program in radio astronomy with a professor up in Brevard, which is when I got to first use the Pisca telescopes. And that was like the coolest thing I've ever done. I did that project and I was like, oh my God, I want to do this again. And astrophysics.
Those are such amazing stories. And I think what is so compelling is that how that science fiction, how those movies like drive like science, in fact. And I love how that's intertwined, how our imagination and our creativity drive like our investigations and our search for the truth. So Ziggy wants to know, is there life on Titan because there's water?
Sure, I can take this one. So there actually isn't water on Titan. There is methane. You might be thinking of Europa. That's one of the other moons in the solar system that has a lot of water on it. Titan is, though, really cool because it has a methane water cycle. So here on Earth, we have a temperature range such that we have water in water vapor form up in the sky, like the clouds and the air. We have water in solid form. We have the ice caps on either side, and we have water in liquid form in the ocean. So here on Earth, we have all three phases of water. And that is one of the things that makes life possible here on Earth. On Titan, it has all three phases of methane. It has methane in a vapor, in a liquid, and a solid in different places around the moon. And it is possible that makes life possible on Titan. We don't know for sure yet, but that is a super interesting area of research. And a lot of astronomers are looking to like missions to Titan and stuff so that we can learn more about that methane cycle and learn about how, if that makes life possible on Titan.
So exciting to think about that. So Miranda wants to know, are clusters of stars an actual group, like within a solar system, or are they just placed in a group by astronomers?
This is my research, so I'll take this one again. So clusters are we use several different terms in astronomy. It gets a little bit confusing sometimes. We call them clusters, but we also call them associations. And there is a subtle difference between those two. But clusters are a real actual group in space. They are gravitationally bound to each other. They're much larger than, say, a solar system. Our sun is just one star, and a whole cluster is much, much larger than that. Hundreds of stars, maybe even thousands for some of the clusters in the solar system. But they are an actual group. And the reason they are a group is because they all formed out of the same cloud of molecular gas. So there are big, gigantic clouds of molecular gas, hydrogen gas, that is, floating out there in the universe. And eventually those will sort of gravitationally collapse inwards on themselves and form sort of a stellar nursery, like the Orion Nebula, which is a stellar nursery, and then form a whole bunch of stars out of that same cloud of gas. And all of those stars, when they're done forming, they'll be, in roughly the same area because the cloud wasn't that big, and they will all have roughly the same age because it all collapsed inwards at the same time. So those are sort of the features that we say makes a cluster.
That is totally fascinating. We have another question from YouTube. If you could have access to any instrument in the world to assist you in your studies, what would you choose and why?
I think just because it's brand new and super cool, I would want to have immediate access to the to JWST, so JWST is the new flagship telescope that just got sent into space. It's like a $10 billion project. It just recently made it to the Lagrange point where it's supposed to orbit. But that's an infrared telescope, and it's the biggest telescope we have in space, and it's supposed to see the farthest we've ever seen. And we're supposed to learn, hopefully going to learn a lot about planets and their atmospheres, which is something that I'm interested in, but also about some of the earliest galaxies. And it's big news right now. So that's my answer. I'm sure probably lots of people also agree, but it's yeah.
Awesome. And we have a talk today by one of the project scientists, Dr. Stephanie Malam, a little bit later today about JWST. So everybody should be sure to join that. Did anybody else want to weigh in on instruments? Okay. So Jasper wants to know, what is your opinion on the TRAPPIST-1 system, and how much do the other planets' gravitational pull make life more likely?
So I can take this one. For people who aren't familiar, the TRAPPIST-1 system is a system of exoplanets. There's about 7 of them. They all orbit about 40 light years away from us. And they're all about Earth-sized, and they are all potentially in the habitable zone, which is super cool. What's different about the TRAPPIST-1 system from our own system is that it actually orbits a dwarf star, and they orbit very closely to that dwarf star, which is how they're able to be in that habitable zone. Basically, the dwarf star is smaller and cooler, so they have to orbit closer such that there could be liquid water on the planets. But what's also interesting about the TRAPPIST-1 system is that because they orbit so close, they are what we call tidally locked, we think. That means that basically only one side of the planet faces the star at any given time. So you can imagine what would I say? The environment on the side that faces the star could be really hot, and the environment that never sees the star is really cold. But I think TRAPPIST-1 is super interesting because, it's possible that there could be water there. Now, I think what's important to note about the TRAPPIST-1 system is that the star is very active. And so those planets are probably receiving a lot of intense radiation, which would make life difficult. But I guess this question is about the planet's gravitational pull, and how the pull from the other planets would affect them. I'm not entirely sure. I guess because they orbit closer together than our own solar system. I want to say you can fit the entire TRAPPIST-1 system within our own solar system. But as far as I know, they're all orbiting in fairly stable, normal orbits. So I'm not sure the gravitational pull on each other. I don't think there's any worry that there could be like an ejection or something like that from the solar system. But as far as I know, all the planets are about Earth-sized, so gravity would not be too different on those planets, just based on their mass.
Very cool. So a friend from chat wants to know, or from the YouTube chat, does the crescent moon look backwards for somebody in Australia compared to somebody in the US? It's a stumper.
I've never been to Australia, but I'm pretty sure it should look the same.
Okay, it looks like there's agreement. All right.
That's all I got.
All right. Okay, Annika wants to know, do you have a favorite planet or constellation and why?
So I'm gonna take this one or part of this one. So my favorite, I want to answer my favorite star is called Vega. It is the sixth brightest star. It is the brightest star in the constellation Lyra, which is also probably my favorite constellation. Lyra is supposed to be Orpheus's lyre from the Greek myth of Orpheus and Eurydice. If you want to look that up, it's a summertime constellation. So it's really good to see in the summer, which is nice because it's not super cold when you go out to look at it. And it's pretty easy to find.
Does anybody else want to share their favorite planet or constellation?
I'm going to take the really basic answer and say my favorite planet is Saturn. And I just really like the rings. I think the
it's
rings
mine too, and that's why it's my favorite too.
Yeah.
And I just learned that the rings are temporary and they're disappearing.
Mm-hmm. Yeah, I think the rings are the coolest thing. And you see them in the pictures, but I never thought that you could actually like see them. Like if you have you have a powerful enough telescope, you can see them, and it's really fun just like sitting outside. You see the rings. You're like, wow, they're there. They didn't lie to me. So that's my answer.
My favorite star is probably Proxima Centauri, just because it's I dropped my headphones, sorry. Just because it's the closest one to us. And that being said, it's still 4 light years away. So that's pretty far away still. But yeah, just because it's the closest to our reach. Yeah.
I'll go. I think the planet Jupiter is really cool just because of kind of how massive it is. Earth is pretty big. I'd say it's not that small compared to a lot of things that we know, but there's like a storm on Jupiter that you could fit 3 planet Earths in, and it would still be smaller than that. And that's like pretty crazy to think about.
I guess I'll go. Salem actually took mine. My favorite star is the star Vega. And Callum took my favorite planet, which is Jupiter, because the moons of Jupiter are really cool. I really like the moon Europa that orbits Jupiter, which is an ocean moon. So the whole moon is covered by a global ocean, covered by a layer of ice.
Awesome. Thank you, y'all. Okay, so someone wants to know, what is the Lagrange point?
So a Lagrange point is where, so in a 2-body system, for example, so like say the Earth and the Moon, a Lagrange point would be a point where the gravitational energies from both the moon and the Earth cancel out completely, or just about completely, and so it takes very little energy to just hold a position there and stay there in that position. So
awesome. And that's where James Webb is sitting right now, in the Lagrange point 2, right? Because it takes like not that much energy to sit there and look out. Okay, Philip wants to know, I think this one's for Colin, how much does the whole Earth weigh?
All right. I'm going off of attempted memory here. I think it weighs about 6 with 24 zeros after it kilograms. Oh, Riley's giving me thumbs up. All right, I'm right. So really, really big, weighs a lot. That's, about 24 zeros more than, or 23 zeros more than any person will ever weigh. So, yeah.
All right. How long would it take to travel to the nearest exoplanet?
So the nearest exoplanet is Proxima Centauri b, and Proxima Centauri is, Riley, correct me if I'm wrong, about 4 light years away from here. So it would, if you could travel as fast as light, it would take 4 years to get to the nearest exoplanet.
And we can't travel that fast, right? So longer for us.
Yeah, for
All
reference. Right. I think the trip to Mars is something like 7 months, and it would be good if I knew how far away Mars was, but that's just within our own solar system. So I would anticipate many years to get to Proxima Centauri with current technology.
And DJ asks, have you all been following the James Webb Telescope? What discoveries are you potentially anticipating?
I think most astronomers have been following it pretty closely. The James Webb Telescope, for a little bit of background, is a project that has been in the process of being built for about as long as I have been alive. So it's been going on for a while. A lot of astronomers are very invested in finding out, where all this goes. One of the really cool discoveries that we might learn from the James Webb Telescope is that it should be able to observe exoplanet atmospheres. So that we could actually learn about, like, if these exoplanets have atmospheres, what are they made of? Are they made of things like oxygen and nitrogen, like Earth's atmosphere is made of, or are they made of other things? And so that's one of the cool things that we might be able to learn with James Webb.
Another cool thing James Webb is doing is because it's an infrared telescope, it can actually see really, really, really old galaxies, some of the oldest galaxies that we've ever been able to observe. And I think that's really interesting when we're thinking about studying how the universe was so long ago, the earliest times that we've ever seen. Yeah, I think that's super cool.
Yeah, kind of piggybacking on the infrared stuff. So the James Webb will let us look at exoplanets we've not been able to look at ever before, really. Nor before this, it's been really difficult to get like a good image, I guess, so to speak. We're not looking at it with visible light. But from that image, like they were talking about, we can kind of look at their atmospheres and see what is in this atmosphere, what are the components. And one of the things that could be really cool for is we could find traces of things like oxygen or elements that, from what we know, pertain to alien life. So, it's a big if, but we could potentially find signs that there might be life somewhere out there in the universe, which I think would be the coolest discovery like ever.
I think so too. So can life develop on one of those tidally locked planets?
I suppose in theory, it could be possible. If all of the conditions were met, you could imagine on a tidally locked planet, there might be like somewhere on the pole where the temperature was just right, such that there was liquid water. But of course, it's not just as simple as liquid water. You also need like an atmosphere that is conducive to life. And right now, all we're really doing is looking for life on Earth, but it's entirely possible that there's life elsewhere that functions in a different environment than Earth's environment. So my answer is maybe. It's really hard to know for certain, though. Yeah.
All right. So Ziggy wants to know, how are gas giants formed?
So when a solar system is forming, so you have kind of the sun or like a star in the middle of this like really big like gas cloud. And so as the sun is like rotating and gathering mass, it causes the gas cloud to form into kind of like a flat pancake. And so as the flat pancake is rotating, gas can begin to and like rocks and stuff can begin to form into like balls, and they're all like gravitationally attracted to each other. And so as those balls like come together, like rocks and stuff, they begin to gather more mass, which gets more gravity. And so it just kind of gathers gas that way until you've got a really big planet that has a rocky core and kind of a gaseous atmosphere on the outside.
So cool. So Lauren has a daughter who's 10, who's interested in Stephenson 218. What is special about it and where is it located? And my follow-up is, what is it?
So full honesty, when I saw this question in the chat, I did Google Stephenson 218 to find out what it is. Stephenson 218 is a red supergiant star. So it's a star that is in the last stages of its lifetime. So the sun right now is sort of in the main part of its lifetime. It's fusing hydrogen in its core. It's going to keep doing that for a long time. But once stars run out of hydrogen in their core, they have to do other stuff. And that is a little bit more unstable. You know, hydrogen's pretty stable. It's a good fuel to burn. The other stuff they burn is a little bit less stable. So they tend to turn into these red supergiant stars, which are very, very large stars. They expand outwards a lot. They're a little bit cooler on the surface than our sun, which is why they're red. That's because their surface is a little bit cooler and they're much, much larger than our star. It will continue to be a red supergiant for a little while until eventually it is going to explode. The stability of that process, it's going to run out of even the less stable fuels. It's not going to be able to support itself anymore, and it's going to go supernova and potentially turn into a black hole. So that's one of the cool things about Stephenson 218. Another thing that looks cool about where it's located, it is in the constellation Scutum, which is, and it is possibly within a cluster in that constellation. So there's an open cluster in that constellation that this star might be a part of. We're a little bit not sure if it is actually a member of that cluster, which is a problem with clusters. It's really hard to tell what's in them and what isn't. And so that is a cool thing about where it is located.
Very cool. Well, I certainly learned something new. So thank you for that. So are there any new technologies in development to make space travel a lot faster? Light speed, for example. Wormholes.
I think the answer is always yes, but off the top of my head, I don't know specific things that are being worked on right now. I think, rocket technology is something that's always being adjusted. I know, for example, I think there is work being done into so for example, you mentioned light speed, right? One theory is that we could use the power of light to propel things into space very fast over time using something called light sails. So essentially you build a giant structure that can basically it's supposed to be hit by light. And because the way light can impart energy to things just by hitting it. But obviously a light photon is one light photon is going to be a very, very, very small change in energy, right? We're thinking of like E equals mc squared, essentially. And so, but this idea that you could generate a giant sail, sort of like on a boat that catches wind. Instead, we're catching light, and that would propel our object hopefully close to the speed of light. But it would basically allow it to accelerate. The problem is it's going to take a long time to accelerate something. But eventually, once you get it up to speed, it would be moving very fast. So that's like one example.
When you say large, what's the actual scale? Like, what's large mean?
I get that. I guess the scale depends on how big of an item you're trying to ship through space. But I guess, there are things that could be propelled. Like if the item is small, you wouldn't need a very big light sail. For example, if you wanted to put like an iPhone sized satellite in space, you could put a light sail on it that probably wasn't that big, and it would get moving eventually. So yeah, the size is definitely going to vary as to how big the craft.
But probably not that big. Riley does mean like football field size.
Okay, I was looking at and I'm like, is this planet sized? Is this like,
for like an iPhone sized object, we're talking like a football field sail.
Okay, because, so that gives me an idea of the relative scale. Awesome. So Jasper wants to know, with the gravitational pull between them, and I'm not sure between what this is, but so Jasper, if you can give me a little bit more information, this may be going back to those tidally locked planets, but would the gravitational pull between them be like Jupiter to Europa and make it have a good magnetic field? Okay, yeah, TRAPPIST one. Okay, thanks, Jasper.
So Jupiter is very, very big for a planet. And none of the TRAPPIST planets are as big as Jupiter. So I don't think any of them would have the sort of the giant scale gravitational pull that Jupiter has around its moons. So I don't think that the gravitational pull there would be, there is more of them. But, that sort of just complicates it. It doesn't necessarily make it stronger. It just makes it weirder because now you've got 7 things pulling in all sorts of different directions instead of one large thing like Jupiter pulling on a much smaller thing like Europa. Now you've got 7 very similar sized things all pulling on each other as they orbit the star differently. So you just sort of get more weird gravitational pull instead of stronger gravitational pull like Jupiter has.
Very cool. So someone's asking, can a plant grow on the moon or Mars?
So the moon and Mars both have a lot less oxygen, and not as much atmosphere as the Earth does. So I suppose theoretically, yes, but it would have to be in a very specific place because they also need water to grow, and they would also have to be very resistant to solar wave, sunlight and radiation, because as they don't have a whole lot of oxygen, they don't have a lot of atmosphere, so they don't they can't protect from solar radiation as well. So it would have to be a very specific kind of plant that can be able to handle that.
So humans could potentially grow plants in these places, but we would have to create a place to grow them that has the oxygen, the soil, the proper soil, the water for them to survive. So we're not gonna, the rover's not gonna find a plant just growing on Mars as it's traveling around. So Ruxin wants to know, how close does a planet need to be to a star to be tidally locked?
It definitely depends on the size of the star or planet that the object is orbiting. Like, for example, Mercury, the closest planet to the sun, is tidally locked with the sun. But then also the moon is tidally locked to the Earth. So it really depends on kind of the size of both the object that is orbiting and the object that is being orbited.
Cool. Was the sun part of a cluster or association like Pleiades?
Yes. So because the way clusters form from those clouds of hydrogen gas that collapse inwards, that is the same way as the way that all stars form. All stars form from clouds of hydrogen gas that collapse inwards. So the current theory in astronomy is that all stars form within clusters or associations, and then those associations sort of break up over time. So the sun is 4 billion years old. That is very old. We don't have any associations we've ever found that are quite that old, I don't think, because they pretty much all break up before they get to be 4 billion years old. Unless they're like very, very dense, then they might live out that long. But the vast majority of associations break up long before they get to even 1 billion years old, much less 4 billion years old. So the sun was once part of an association, but all of its friends are sort of scattered around the galaxy now.
That's so cool. All right, here we go. Ziggy wants to know what caused the Big Bang.
Well, that's the great question. I don't think we know, and I don't know if we'll ever know. It's really hard because the Big Bang is the first time, as far as we know, ever. And to see beyond it is sort of a greater philosophical question. You know, I don't know if you can see, basically the Big Bang is just the creation of our universe. And right as of now, there's no way to peer beyond our universe as far as we know. So the answer is we don't know. Though there are plenty of theories that are really hard to prove, that people think about all the time. Yeah.
Do you have a favorite theory?
I don't know if I have a favorite theory. I think a very interesting theory though is, which I don't know how much I buy into it, just because a lot of it is very philosophical. But one theory that exists is that like this idea of like multiverses. So like there's this idea that our universe is a break off of another universe, and it broke off because there was a black hole that basically pinched matter from one universe to make another one. That's one theory. That's not the only theory. There's plenty of other theories, but I think that one's interesting at the very least to think about.
All right, cool. Is it true that the Earth is never at the same place, as it orbits around the sun and sun orbits around center of the Milky Way and the Milky Way orbits around something else?
Yep, that is true. Yeah, so it takes, I can't remember, a couple million years to orbit around the galaxy, for the sun to orbit around the galaxy. So we were, roughly in this position a couple million years ago in the galaxy, but probably not exactly in the same position. And as you said, the galaxy itself is moving. So in terms of like absolute space, which is like a very weird thing to think about, because like, where is the 0 point if your scale is the whole entire universe? No, the Earth is never in exactly the same spot as it was ever before.
That's a cool thing to think about. Frank wants to know, what is the fastest possible speed at which our space probes can travel? And is there a different maximum speed if humans are on board?
I think for the most part, there's not much regard for the humans on board. It's more so training the humans to adapt to the speed, rather than going slower. In regards to the exact speed, I'm not sure on that one.
So actually, I don't know too much about the maximum speed of what we've made before, but I know one of the fastest things that we've actually ever made was completely accidental. It was the test cap for a underground nuclear bomb test. So basically we were like blowing up really big bombs underground, and the top of one of like these tubes blew off like a potato cannon and flew up, and there was a camera monitoring it, and we only captured, I think, it in one frame. So we don't know how fast it was going. But if I remember correctly, it was about like the estimated lowest possible speed was over 120,000 miles per hour, which by itself, I think, makes it one of the fastest man-made objects of all time. We don't know where it went. It might have reached space. It might have disintegrated in the atmosphere because it was moving so quickly. But yeah.
Wow, that's a very interesting story. Kind of scary. So DJ wants to know, why does Saturn have rings?
So Saturn has rings sort of for the same reason that the Earth has a moon, which is that in space stuff likes to orbit other stuff. In Saturn's case, the stuff orbiting Saturn in the rings is a bunch of very tiny little bits of stuff that are all orbiting around. And those bits of stuff happen to be ice mostly, and ice is shiny. So that makes the rings very bright, which is why we can see them, as opposed to the rings around Jupiter or Neptune or Uranus, all of which have rings. They're not as pretty as Saturn's. And one of the major reasons that Saturn has those very shiny rings is because Saturn's moon Enceladus has an ocean on it, just like Europa does. And on that ocean, there are some geysers that shoot water into space. And so Enceladus is sitting there constantly just shooting a whole bunch of water into orbit around Saturn. And that water then freezes and goes around Saturn for a while before it falls onto the planet. And that is what makes the rings of Saturn.
Very cool. So Shani wants to know, what is your dream job? Like after school, what's the plan?
I hope to be a research professor at a university. I definitely want to go to grad school and do a PhD program. I currently want to go into research on exoplanets, similar to how McKenna and Riley are doing, because that's just something I find really interesting. I want to do research into that. That's probably my dream job. I don't really care where, as long as it pays well.
Does anybody else want to wait? Oh yeah, okay. Sorry, Riley.
I think my dream job is doing something where I'm able to, study space, but also excite others about space and engage with the public. As being in grad school in the middle, I'm definitely looking towards my future and thinking about lots of different career paths. But one that I think is appealing would be something like, working in a museum as a curator, or someone who helps teach the public about space.
I love that answer so much. We have two astrophysicists on staff at our museum, two research scientists who also do a lot of public outreach, and you may have already met them because they've both done programs this week during astronomy days. Okay, Matthew wants to know, can we use what the sun does to make our rockets go faster?
I assume we're talking about like nuclear fusion. And I suppose, yes, you could make a nuclear fusion reactor and put it on a rocket ship, basically like blowing up like an atomic bomb on a rocket. Yeah, that could work. I don't know if we've ever mastered that yet, though, but that would certainly supply the energy needed. I don't know if anyone else can comment on that.
I know kind of similarly, there was a plan for a little bit where we basically have a rocket that would drop nuclear bombs out of its bottom that would blow up and hit like a plate behind it. And those would propel it to really fast speeds, which I guess is kind of similar. That did not work out very well. It was really difficult to make work properly.
It seems dangerous.
Yeah. Yeah.
Isn't that what they do in Firefly, like in that TV show? Don't they have like you haven't seen that? It's like a science fiction show, but I think that they use fusion. So what is your favorite image from Hubble? There are a lot to choose, amazing images to choose from.
I like the pictures of the nebulas and clusters because I study those. Although I feel like if you've got to pick one, you've got to go Hubble Deep Field because it just sort of revolutionized our idea of how big everything was. So yeah, probably Hubble Deep Field.
It's an amazing image. Maybe we can drop a link in the chat to it. Shani wants to know, what's the most interesting thing you've ever learned about astronomy?
I'm trying to remember back to last semester when I took my intro to astrophysics class at UNC. Something that I think is really interesting is definitely like black holes and the event horizon. Like we don't know anything that happens inside a black hole. We just know that like if a star is above like 3 solar masses, that it's eventually likely going to be a black hole. But we don't know what happens. And just the fact that even light won't escape from a black hole and the amount of gravity that it has, it's crazy. So that's something that I think is really, really cool.
Yeah. On the same idea of like intense gravity, I think what's really cool about space is like how light travels and how gravity affects how light travels through space. And so, for example, it's possible that like light can bend, and if there's like a place of gravity so strong, because essentially gravity, like if something is so massive, it has so much ability to like warp, as we know it, space-time, which when we get into the world of space-time, it just kind of all feels like crazy theory. But I think it's cool, like because light can bend, we can actually see copies of things, because like we see light from it somewhere and then that light travels somewhere else, and there's like maybe like a really like big galaxy cluster that's got a lot of mass and it's able to like warp light from elsewhere, and so you see a copy of that other thing in space just because the light bends and points back at us. I think that's really crazy.
That is so cool. And I feel like we could go for another hour because these questions are just amazing. And I have a whole list of questions that that I want to ask. But I'm going to ask one last one because I think it's a good one to end on. So Lauren's son is 6 and obsessed with space. And they want to know, are there any good programs to sign him up for? So any good clearly besides astronomy days at the museum?
So I know every year in the spring, UNC does Physics is Awesome Day. I'm not sure how that's being handled, but I know that should be happening hopefully towards the end of this semester, and that's an opportunity to learn more about physics and astronomy. Aside from that, I would recommend. So I know there are like local groups that do observing nights. I'm not sure about at what capacity they're working right now, but UNC usually has observing. Right now, the telescope is under renovation. So unfortunately, we're unable to use the telescope for at least, I think, probably another semester. So that might hopefully happen in the either summer or fall, that we would be able to do like an observing night. But I know that Duke, they are hosting stargazing events. So there's on the Duke stargazing, I think they have a website that you can look up, and that's super cool. It's free to the public and you show up. There's also like amateur astronomers of, I think Chapel Hill is a group that does.
So we have Raleigh Astronomy Club in Raleigh, and Chaos is the Chapel Hill one. And these are both, the Raleigh Astronomy Club is so awesome because what they do, they will loan out telescopes. So if you join the club, you can get it. And that's a way to see if this is something that you want to do before making like kind of a hefty purchase of a telescope. They have, there's star parties all throughout the state during the North Carolina Science Festival, which is going to be in April. And so so Chaos and RAC have observing nights as well as monthly programs. So kind of like, we have astronomy days, we have all these programs in 1 week. I know at least Raleigh Astronomy Club has one a month that they're doing them virtually now, but eventually they'll be back to in person. So there's lots and lots of different options, I think, out there for folks who are interested in astronomy. Oh, I want to also point out, Full Steam has Astronomy on Tap as well. That is, I think it's a monthly program there, and that's
next
a family.
Tuesday.
Sorry,
I'm on the organizing.
I know. I just saw the notification of it. Yeah, and so that is a family-friendly program as well. So there's a lot of astronomy out there, and if anybody wants to email me, I'm happy to connect you with some of these organizations. Well, y'all, thank you.
Oh, I have one more thing. Moorhead Planetarium. We are open on the weekends, and we have different like pre-rendered shows. We also have a live show both on Saturdays and Sundays, and we are also holding sky watching events. So that's if you live in the Chapel Hill area, then that's something to look into.
Awesome. Y'all, thank you so much. This has just been such a fun program. Q&A is always my favorite part of a presentation, so having an entire program that's just Q&A is just so much fun. So thank you for joining us. I do want to say that we have really cool Astronomy Days t-shirts and hoodies available at the museum store. So if you want to commemorate this year's event, we are featuring Venus. So really awesome shirts. There's a discount for members. I want to thank our sponsors, North Carolina Space Grant and Pepsi. And then I want to thank our museum members. Your membership supports programs like Astronomy Days. And if you are not yet a member, please consider joining. And with that, and I do want to plug our next program is with astronaut Stan Love. Is going to be talking about why going to Mars is hard. So that will be at 11 o'clock. So make sure you jump on that one. Everybody have a fantastic day. We will see you at the next one. Bye-bye.